We want to now look at monotonic transformations of utility function. We looked at how we can mathematically represent our tastes or preferences through a utility function. Now, the idea is that the utility function that represents those preferences is not unique. Those same preferences can be represented by a monotonic transformation of that utility function as well. And by same preferences, we mean that when we graphically depict our preferences, we'll get the same shapes of our indifference curves, and numbers on the indifference curves will have the same order, though they can have different magnitude. So the idea is that if you have one utility function representing your preferences, that utility function is not unique. Any monotonic transformation of it will represent those same preferences. But now, what do we mean by monotonic transformation? Now, monotonic transformation of utility function involves adding or subtracting a number from the utility function. So if you have a utility function ux1, x2, so it could be ux1, x2 plus minus 2 or some number. Multiplying the utility function with a positive number. So we could have like ux1, x2, we could multiply it with say 2. Taking the positive power, that positive power could be a whole number or fraction of the utility function, and taking the natural log of the utility function. So if I have a utility function, ux1, x2, if I apply any of these monotonic transformations to it, that resulting utility function will still represent the same preferences. The implication of this is that once we find one utility function that represents a particular set of tastes, we can find a large number of utility functions that also represent those tastes by subjecting that original utility function to different monotonic transformations. Because if ux1, x2 represents a particular set of tastes, a times ux1, x2, where a is a positive constant, will also represent those same tastes. Similarly, ux1, x2 plus minus a will also represent those same tastes. So if we know one utility function that represents a particular set of tastes, by applying a variety of different monotonic transformations to it, we can find a large number of utility functions that also represent those same exact tastes. And by same tastes, we mean that when we graphically represent those preferences using indifference curves, we get the same shape of our indifference curves, and the order of the numbers on the indifference curves is the same, although they may have different magnitude.